Chapter 5 is on the various commands and concepts that have to do with Unix security. The first of these concepts is to note that Unix is a multi-user operating system, and that's exactly why we need security. We will be sharing the computer, in other words the various files on the computer and other resources, with many other people. And it is entirely possible that one of those other people might do something accidentally or deliberately that we don't want them to files that we feel are under our control. This is a pretty widespread phenomenon, as you're probably aware, and so the notion of security was invented for the various files, directories and other resources that we have on the Unix system. That's what this chapter is about. But first, what does it mean to say that Unix is a multi-user operating system? I know what you think it means, but what does it specifically mean? Well, the actual definition is in two parts. The first is multiple people may be connected to and running programs on the system at any given time. In other words, multiple people are capable of logging on simultaneously. But that's not all. It's not enough to say that there are multiple people logged onto the system at any given time. Also, we must also say that each of these users has a separate set of access privileges. So depending on how each person identifies themselves to the operating system, they will get different permissions to do different things on the computer. So if I log in as me, I'll get permission over, say, my files. And if I have somebody else's username and password and I log in as them, then I will not have the same permissions as I had before to access my own files. I'd probably have access over their files instead. So, are all operating systems multi-user? Well, clearly no. I mean, DOS is the obvious example. DOS allows only one person to log on to the system at any given time. Well, they don't even have to log on to. It's just one person is using the system. And there's only one set of access privileges. Everybody gets the same set. No matter who sits down in front of the computer, everybody is allowed to do the same thing. Essentially because there's no log-on procedure to identify different people. But what about some of the more sophisticated operating systems? And I will speak now of the common variants of Windows, because I'm guessing that some of you may be familiar with Windows. So let's have a look at a little table of those. Unix, as we can see, is fully multi-user because it supports simultaneous users, each of which has separate privileges. Now, with the advent of Windows Terminal Services, which is an addition to the Windows NT family of products, Windows 2000 and Windows XP are now able to support simultaneous users on the one computer, all logged in. And I'm not talking about networking sharing of files. That's simply making files on this computer available to another computer. And that's not the same thing at all. This is people logged on to this particular computer, running programs in the same memory space as other users. So Windows 2000, Windows XP, yes, it fully supports simultaneous users with separate privileges, and so is a true multi-user operating system. However, its predecessor, Windows NT, which did not have the Windows Terminal Services feature, was only partially a multi-user operating system. Each person that sat down at the computer could identify themselves to the computer with a logon name and a password and would get separate privileges over the files on that computer. However, only one person could do that at any given moment. Now, a lot of you will be using Windows 5 or Windows 98, and you will be seeing a login screen occasionally when you log in, when the computer boots up, for example. So you might go so far as to think that your Windows 95 or 98 system is a multi-user system as well. Well, not really. It isn't really in any true sense a multi-user operating system. That is because only one user can log in at any given moment, and each user that logs in gets the same set of privileges as any other user. At least, that is, privileges over the files and resources on that computer. On the network it may be slightly different, but I'm not talking about a network environment here. I'm talking about just this computer. It is true that in Windows 95 and Windows 98, each user that logs on gets a different configuration, a different set of settings, if you like. But that's not really anything to do with multi-user operating systems. Anyway, let's move on. Core to this particular chapter are two specific concepts. One is called a user. And most people are probably fairly familiar with what a user is. It's simply a system identification that allows each user that logs in to identify themselves for resource access purposes, in other words, for security purposes. So what that means is if we're going to have security on the system at all, if we're going to make sure that the right people are able to perform their actions in the right way and the wrong people are not allowed to, then we have to have some way of identifying who's who. And that's what a user is. It's typically a short string of characters like Fred or mVirtue. Incidentally, recall that root is also a system ID. It's a user. It's the special user that has permission to do anything on the computer, has access to all resources. And when I say resources, I'm talking mostly about files. Well, files and directories, of course. But in Unix, as we'll see in a later chapter, it is possible to access all sorts of other devices that are attached to the computer, such as printers, tape drives, floppy disks, CD-ROMs, etc., etc. And each of these has similar permissions to a file, similar resource access permissions to files and directories. So I'm just bundling them all under the one heading of resources, but it's mostly going to be talking about files. Anyway, so a user is one main concept. There's a second main concept that we need to talk about as well briefly, and that is called a group. It's fairly easy to imagine a scenario where 50 different users all require an identical set of permissions because they're all part of the same team or part of the same department or what have you. Now, maybe they all have individual permissions over their own files, but they also might want to share files. So what we do is we make each user a member of a particular group, and that group might be named after their department, such as the sales group. And if the sales department wishes to share documents around itself, then they can specify various permissions for that document as far as the group is concerned. So we could say that the group has permission to read this file, the group has permission to modify this file, and thus any of the members of that group inherit those permissions. The upshot of all this, for example, is that if you have a file that is able to be modified by the sales group, then all the users that are members of that sales group are thus able to modify the file. So those are the two initial concepts that we have to get our head around, and they're both rather simple. Now let's have a look at some of the basic commands that are available for this sort of thing. We have some security-related commands that include whoami, ID, SU, and new group. And I'll just give you a brief demonstration of how each of those is used. We'll start with whoami. Whoami is a very simple program, or it's actually the who program that is running with the specific arguments of mi. And we run it, and we find out that we are running on a particular computer called the following. That's everything up to the exclamation mark, followed by our username, which is possibly the most important thing here. mVirtue is my username, followed by the terminal that I'm logged in on, which is PTS/31, which may or may not mean anything to you, and the date that I logged in, which was June 26th, 12:31, which is about half an hour ago now. This command is useful if you ever walk up to a terminal where somebody's logged in and you need to know exactly who is logged in, or what the terminal identifier is, or how long the person has been logged in. Let's move on. We'll have a look at the ID command. ID is also a simple command. Just type in ID and you get the following information. You learn again your username, and you also learn your user number. Every username has its own number. In this case, mVirtue is 3040. But now I also find out my group ID, which is users. So I am currently thought of as being logged in as part of the users group, which happens to be group ID 100. Now, the third thing on the list is called groups. And that is actually a list of comma-separated group names and group IDs of which I am a member. But it turns out that I'm only a member of one group, which is the users group. If I was a member, say, also of the sales group, then I would see 100 brackets users followed by, say, 200 brackets sales, separated by commas. So I guess we need to establish the relationship between your current group ID and the list of groups. And the relationship is this. Groups lists all the groups that you are considered to be a member of, and your current group ID shows the current group that the system is treating you as a member of. I'll give you a concrete example of this, something you can hopefully relate to. Let's say my groups were both sales and managers, because I am one of the managers of the company and I'm also part of the sales team. Perhaps I'm the sales manager. In this situation, when I log into the system, I will be automatically logged in as one of those two groups. Let's say it's sales. That will be my automatic current group ID when I log in. But then suppose I wish to access some of the files or programs on the system that are restricted only to managers. What I conceptually have to do is take off my sales hat and put on my manager's hat. In other words, I have to switch my group from that of sales to that of managers. I do that using the new group command. I would say new group managers or something like that and press enter. Naturally, I'm only allowed to switch between the various groups of which I am a member. I can try this command. It's probably not going to work, not only because I'm not a member of the managers group, but there probably isn't a managers group. So there we go, no such group. So the bottom line is, if you're a member of several groups, you might find yourself using the new group command several times during the day to essentially, if you like, switch hats. Finally, it is actually possible, if you like, to assume the identity of somebody else on the system. Needless to say, the only way of doing that is if you know their password. You also have to obviously know their username. Obviously, if you know their username and password, you could just log in as them if you chose to. But it's sometimes a hassle to interrupt what you're doing at the moment by logging out and logging in as somebody else. So instead, the system provides a command called su, which is actually short for super user. Even though we are not necessarily attempting to become a super user, it's S and then you type in the username that you're trying to become. So I know of another user on this system who allows me to use their password by the name of Avon. So I type su Avon, press enter, I'm asked for a password which I will now type in. And now I am known as Avon at this particular computer, but I have not moved. I'm still in the same home directory. I'm not really logged in as them, I'm just pretending to be them. If I logged in as them, I'd end up in their home directory, not in my own. So now I can do things that they have permission to do, but I cannot do things that I have permission to do. What's actually happened here is I have another shell running temporarily. My first shell has been momentarily suspended, and a second shell has kicked into place, in which I am now called Avon. In the original shell, I was known as mVirtue and had all of mVirtue's permissions. That shell has been suspended momentarily. Now I'm in a new shell where I have all of Avon's permissions. So, for example, I could do an ls -l, and I don't even have permission to do an ls -l in this directory. When I'm finished being Avon, I can simply type exit, which will exit the current shell. Remember we talked about exit for the logout command? Well, I'm now back to being mVirtue, and now I can do an ls -l without any trouble. Now if I want to log in as Avon in the same manner and do an su, instead of su Avon, I can do su dash space Avon. Notice the spaces around the dash, before and after. And what that will do is we'll actually do a full simulation of Avon logging in. So I'll end up in his home directory. So the home directory is home Avon here, and I can do an ls -l, and there's his set of files, which is of course different to my set of files. Notice that he is a member of the same group. I can run the id command now and find much the same information as if I was mVirtue. Again, I simply use exit to return to being me. So that's a reasonable summary, introductory summary to users and groups. In the next modules we will look at how to modify our files and directories such that they are accessible by certain users or groups and not accessible by others.